Machine learning models can be highly effective in making predictions or decisions, but their performance hinges on the right hyperparameter choices. Hyperparameter tuning is a process of finding the optimal set of hyperparameters for a given machine learning model. So in this example, we'll walk you through the simplest script to perform hyperparameter tuning using Python and scikit-learn. So let's get started with understanding what is hyperparameter tuning. Basically, hyperparameter tuning is a process in machine learning where you find the best set of hyperparameters for a given model. Hyperparameters are adjustable values that control the behavior of an algorithm, such as the number of estimators in a random forest model or the learning rate in a neural network. And think of it as adjusting the knobs and dials of a camera to take the best picture. So hyperparameter tuning is like adjusting the parameters of a machine learning algorithm to achieve the best performance on your specific problem. In hyperparameter tuning, you define a range of values for the hyperparameters, create a model and use a search algorithm to find the best combination of hyperparameters that results in the best performance on your data set. And the goal is to find the hyperparameters that results in the most accurate and reliable model for your specific use case. The simplest way to perform hyperparameter tuning in Python is to use the grid search CV class from the sklearn.model selection module. So it's a simple example that demonstrates the hyperparameter tuning for a random forest classifier using grid search CV. In this example, we loaded a dataset, split it into features and target, and defined a param grid dictionary containing the hyperparameters to be searched. We then created a random forest classifier and performed a grid search using grid search CV. The best hyperparameters and the best score are printed at the end. And this is a simple example using scikit-learn. If you're working with a deep learning model, you would need to use a different approach like using a library called hyperopt or implementing a custom search algorithm. However, the general idea remains the same, that is define the range of hyperparameters to search, create a model and then use a search algorithm to find the best hyperparameters. Thank you.